Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Aida Shazana binti Hashim. Today I will be presenting our mini project and I will continue with the first one is introduction. IBS is a modern construction technique where structure components are manufactured in a controlled environment, either in a factory or at a specialized on-site casting yard. These components are then transported, positioned, and assembled into a structure using minimal additional site work. So for types of IBS systems, we have five types of IBS system. The first one is precast concrete systems. It's a common types precast walls, column, beam, and stairs. The second one is steel framing system. It's frequently used for high-rise buildings and portal frame. And the third one is formwork system, blockwork system, and trimble framing system, which is ideal for roof trusses and aesthetic eco-friendly structure.
Good morning, everyone. My name is Sarveshwaran, and my metric number is 22120-2005. In Malaysia, the construction industry have long struggled with issues such as labor dependency, inconsistent workmanship, safety concerns, and material wastage. These challenges are one of the main reasons why CIDB Malaysia actively promotes industrialized building system, also known as IBS. So, with using this single slide, I will explain why IBS is critical for modern construction in Malaysia, supported by some real local applications and outcomes. Superior quality control is the first advantage of IBS. In conventional Malaysian construction projects, quality often depends on site labor skills, which vary significantly, especially with a high dependency on foreign labors. IBS addresses this by shifting construction activities into controlled factory environments. In Malaysia, precast concrete components are commonly produced in factories certified under CIDB. Some components examples that are precast wall panels, beams and columns, and staircase and slabs. This approach significantly reduces common defects seen in conventional construction. As a result, IBS buildings in Malaysia demonstrate higher construction quality with lower rework rates and improved long-term durability. The second advantage of IBS is enhanced site safety and cleanliness. Traditional sites in Malaysia often involves extensive timber work, on-site bar bending, large material stockpiles, and these conditions increase the risk of workplace accidents, non-compliance with DOSH safety requirements, and some misplacing of things which occurs or um, lead to some injuries. Traditional sites in Malaysia often involves these works. With IBS, the construction site becomes mainly an assembly area more than a construction site. For example, high-rise residential projects in Klang Valley, such as those using precast and PPVC systems, show significantly cleaner sites because components arrive readily for installation, and there is minimal cutting or casting on site. This systematic process involves compliance with Occupational Safety and Health Act, also known as OSHA, and reduces accident risk, particularly in dense urban areas where site space is very limited. So IBS therefore supports not only productivity, also better safety management and regulatory compliance. Finally, the third advantage of IBS is IBS is eco-friendly and efficient, which aligns strongly with Malaysia's sustainability agenda. In conventional construction, material wastage, especially timber formwork and excess concrete, is a major issue. This leads to a high disposal cost and environmental impact. With using IBS, we can minimize this problem, CIDB Malaysia reports that IBS adaptation can reduce construction waste up to 50% and shorten the project duration by 30 to 40%. By this, we can reduce the dependence on manual labor significantly. A good local example that happened in Malaysia is the public infrastructure projects or housing development. They have repetitive designs which allows IBS component to be reused efficiently. Additionally, IBS supports Green Building Index, which requires by reducing material wastage, lowering site disturbance, and improving construction efficiency. This makes IBS not only environmentally responsible but also economically attractive for Malaysian developers. So to conclude everything, in Malaysia construction industry, IBS has proven to improve construction quality through factory controlled production, enhance site safety and cleanliness, especially in urban projects, support sustainability goals while reducing time and cost, and IBS is no longer an option. It is a strategic necessity for Malaysia construction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noor Atta binti Hamzah. My number metric 2212034226. So I will continue my part, which is part on calculation construction area. So for construction, for ground floor, we have 5 area. And then for the construction for roof, we have 3 area. So this is total of construction area from ground floor, first floor, roof area, and the total of construction area. So for structural system, we use beams, column, floor slab, and roof trusses. So for wall system, we have internal wall and external wall by prefabricated wall panels and blockwork system. So IBS score calculation. This is IBS vector structural system. We calculate by component from ground floor, porch structure, first floor, and roof, and then we total. For the IBS vector, we determine from the table. And for the total of structural system, for the area we have 1318, and for the score IBS we determine 37.24. So move to the IBS calculation for wall system. For the external wall we use block system. The total length is 279, and the IBS factor we determine from table that use block system. And for internal wall, we use prefabricated wall panel, and the length of internal wall is 192.47, and then we total and then get 471.77. So move to the simplified construction solution. We determine 85 knots of beams at roof, and the column we determine 27 knots, and for the slab we have 18 knots. So for the window we have 14 knots. So overall of this simplified construction we use 100% from IBS. So the total will be 20 points. So move to the IBS score calculation. This is a part of each apart from structural system, wall system, and other simplified construction solution. So after we calculate the total of score calculation IBS, we got 71%.
My name is Muhammad Arif Irfan bin Muhammad Zamri, and my metric number is 2212034008. So for this section, I will explain the design drawing part. The design drawing are divided into two categories, which are 3D drawing and 2D drawing. I will start with the 2D drawing, which were prepared using AutoCAD. Several drawings were produced, including ground floor plan in structural plan and modular plan, first floor plan in structural plan and modular plan, roof modular plan, and schedule for window and door. This slide shows the ground floor modular plan. For the dimension, the drawing was converted from 300mm module to 3M modular coordination. For the beam system, in situ beams are used at the ground floor level. There are 6 sliding door with 1800 times 2100mm and 4 door with size 9000 times 2100mm. The slab thickness for the ground floor is 175mm. For window, there are 1 unit for 600 times 600mm, 3 units of 1200 times 900mm, 7 units for 1200 times 1200. The slide show the actual structural drawing for the ground floor, and all the dimensions shown here are based on structural design requirement and load distribution. Now we move to the first floor modular layout. For beam size on the first floor, there are 15 units of 300 times 500mm, 14 units of 300 times 600mm, and 24 units of 300 times 800mm. For door, there are 5 units with size 1800 times 2100mm and 3 units with size 900 times 2100mm. For window, there are 3 units only with size 1200 times 1200mm. So for slab thickness, it's actually same with ground floor thickness, which is 175mm. This slide show the first floor structural layout with actual dimension. The drawing represents the real structural configuration used for construction and analysis. So we continue for roof floor modular plan. So this slide show for the roof beam, there are 2 units of 300 and 500mm, 23 unit of 300 times 600mm, and 7 units of 300 times 800mm. These beam size are arranged based on the modular system and roof load requirement. For last part, for 2D drawing, I will explain about accessory schedule table. The accessories include window, sliding door, sliding window and door. For window types, there are several size we use, which is 600 times 600mm, 1200 times 900mm, 1200 times 1200mm. And for door, there are sliding door with size 1800 times 2100mm and standard door with size 900 times 2100mm. All accessories are standardized to suit the IBS modular system and to simplify fabrication and installation.
Assalamualaikum, my name is Muhammad Adam Daniel Benazri. Today I will presenting our project using a 3D model developed in Autodesk Revit. So Revit is a building information modeling, BIM. So the software that allows us to create a complete 3D representation of the building is integrate the architectural and structural element into one coordinate model, helping us to understand the design more clearly than traditional 2D drawings. For the overall 3D view of the building, uh, we can see the building form, layout, and height. The 3D models improve the visualization and allows the early detection of design or coordination issue. The model includes the architectural components such as slabs, walls, floors, doors, and windows. For the structural elements like column, beams, and foundation, and each component is model accuracy according to the actual size and position. By using the Revit, we can reduce errors and improve the coordination between disciplines and supports for the efficient construction planning and including IBS or prefabricate component if required. So for the conclusion, 3D Revit is models that helps we can ensure the better design accuracy, coordination, and construction efficiency. Thank you.
As a conclusion, to conclude what did we learned, we took a basic two-story house and proved that by using the JKR IBS catalog, we can hit a high IBS score of over 71.32. It's not just about hitting a number, it's about showing that we can build faster, cleaner, and with much better quality than traditional brick and mortar methods. This project confirms that IBS is the way forward for the Malaysian construction industry, and it's a practical solution that's ready to be implemented right now. So that's all from our group presentation. Thank you very much.